Hello and welcome to another video tutorial on how to use MATLAB. Today I would like to show you a possibility on how to convert large matrices from MATLAB into the equation editor of Word, and this just with the help of a function. But first let's look at the procedure we're going to see. So in Word, if we want to add an equation, we just go here and insert an equation, and if we would like to have a matrix, we can, for example, click here and choose the matrix we would like to have, and then we can start typing in the values. So 1, 2, 3, 4. And this is the professional representation. We can also look at the linear one. So you see here that 1 and 2 are linked with the ampersand, and the @ symbol indicates the end of a row. So 3 and 4 are in the next row. And I can now simply add a row if I just change the position of the @ symbol here and add a few numbers. So 4, 5, 6, add 7, 8, 9. And if I change to professional mode again, you'll see that this is a 3 times 3 matrix. So I'm just gonna copy this real quick. And we can look at what we want to achieve. So imagine we got this matrix as an output in MATLAB. And our goal is now to create the other representation, this one, so we can put it into Word. And how do we do this? Well, with a function. So a function named Word, which simply takes the matrix as an input, converts it to the linear representation, and gives us this in the command window. So let's get started. I'll just leave this window right here as a small reminder. And we change to MATLAB. So we create a new M file and name it Word. And if we open it, we just have our function right here. But we don't need output arguments because we don't have variables to give out. Instead, we just have an output in the command window looking like this. And as input arguments, we simply have our matrix M. And what does the function do? So the function Word outputs a matrix in syntax of the equation editor. And a little more in detail, so we have our input, which is a matrix M, and then we have the output, which is a string, and we can name it S. And to test our function, I can now comment out the first line and define a random matrix with a size of 3 times 3. So if we run this, the command window will show us this random matrix. And to test it, we should also add clear all, close all, and CLC, so it becomes a script more or less. And save it and run. So we always get the random matrix as an output. But of course we can now press this by setting a semicolon here. And we'll just look at the workspace. So what to do next? Well, we have to run through the matrix, and for this we have to check the dimensions of it. So we'll type the command size of M to get the dimensions. And we want to save this into variables, so save it as rows and columns. And if we run this, we get 3 rows and 3 columns as an answer. Next, we need to run through the matrix with 2 control variables that go through the matrix with a for loop. So we are going to write for control variable I equals 1. It should go until the number of rows is reached in a step size of 1. So I equals 1 colon 1 colon R. I can comment this, so this is the number of rows, and the same for the number of columns. So for second control variable J equals 1 colon 1 until number of columns is reached. So this is number of columns, and this has to end, so I'll type end here and end here. And for a test, we'll just set an output here of the current element in our matrix. So M at the position of I, j, and we can just run it and see what happens. So we have our values in the command window here, and to see it in the array editor, I'll just open this by double-clicking on our matrix. So here the 9 values, and we can see through the command window. So the last value is 0.75, which is this one, and the second to last value is 0.34, which is also this one. So it looks already good. So what we achieve right now is that every value of our predefined matrix is displayed in the command window with the help of 2 for loops. So we got a little closer to our goal, but we don't want numerical values to be the output, but string values, which then can be written to our string s. This means that we have to convert the numerical values that we have right now into string values, which then can be the output for the command window. And how do we do this? Well, there's a command named sprintf, which looks like this. And for this, then we have to set a format. So we'll type in here, in inverted commas, %.4f, and then after a comma, the numerical value that we want to convert into a string. So this means now we run through the matrix and every element of it, and every value that we have is converted into a string with this sprintf command. And this %.4f is just the formatted output, and for example the 4 represents the decimal places we want. So if we run this, then you can see that we have 4 decimal places just as we wanted. We can also change this by just setting 2 decimal places or even 7, but right now we just leave it at 4. And now I'll set this into squared brackets and add the @ symbol after a comma, because if you remember, what we want to have is that at the end of each row should be an @ symbol, because we want to then write the next row. And if we run this again, then you'll see that after every entry it has been added the @ symbol. The same can be done with an ampersand, so we can write here the AND symbol, and if we run this, then instead of the @ there will be an ampersand. So somehow we need a case distinction. So at the end of every row there should be an @ symbol, so here and here, and between all the other components we need an ampersand, and at the end of the matrix the function should set a closing bracket. So we need a case distinction. And how do we do this? Well, with an if statement. So we'll stay here with the @ symbol and then enter if and think about what comes next. So the J control variable runs through all the columns, and every time the maximum number of columns is reached, which is 3 here, we need an @ symbol. So this means we can type in here if J equals C, which corresponds then to number 3 because this is the end of a row. But we have to pay attention here because J equals C, so 3 is reached in every row, so after the 3, after 6, and after 9. But the problem is we don't want an @ symbol after number 9 because this is the end of the matrix. So we have to add a second constraint indicated by the double ampersand, in which we say now that we want to write an @ symbol every row as long as we are not in the last row. In other words, now I is not equal R. And now we can run it again to see what it looks like. And as you see here, the program only took the last value in the first row and the last value in the second row, but not the last value in the last row. Next, we want the function to close the bracket at the very last value, so here. Because if you remember from our Word document, here you see that after the last value we don't have the @ symbol, but we have a closed bracket. So to do this, I'll copy this section, so I keep the case distinction. But in this case, it is not if, but else if. So I'll add this here. And now we have to think again, when is this the case? So the last value is reached if the control variable for columns has reached the last column, and if the control variable for the rows has reached the last row. Then I want the function to add a closing bracket. And in all other cases, so simply else, we want the function to add the ampersand symbol. So we can test this again. And if the command window has 9 values, then this is a good sign. And we already see here that after our last value, the closing bracket has been added. And now we can check the other values. So here's an AND symbol, here's an ampersand, here should be an @ sign, so this is true, @ symbol. And just to check at this value, there should also be an @, so yes, it looks good. So now we have this part until here, and what we still have to achieve is that all the ANDs values in the command window are written into one string. And to reach that, there is this possibility to create a string by just saying string is, in inverted commas, let's say ABC. And now we can expand this string by adding square brackets and just entering the word string here again, so the variable. And this concludes to just 2 strings of this kind, and we can do this again and again, and it will always be added an ABC to this. And this is exactly how I want to add this up here. So we just say this here is our string, as well as in this line, and of course in the last line as well. And in the next line we say that S, which is our output later, is the S from before plus the string that we created in the case distinction. So this is this one right here. And this should be added in the other case distinction as well, and of course in the last one too. So now we can save it and see what happens. And we see that this results in an error. S is undefined. So we remember that S should be our output, and if we see here, it only makes sense that we initialize S with the first symbols, so this part right here. So what we enter now is S equals, in inverted commas, \matrix, because this is this little square in the beginning, the matrix symbol. And after this we open a bracket, and if we jump into our structure, then the first value that is added to our S is this one. So this string will be added to our S and also saved as an S. And this is the same for the next value. So again, this one will be added and then another one. And so our S will grow. So let's run this again. And now we see here that this is our matrix so far. So we have our \matrix and then the first entry right here, then the ampersand and the second entry and third. So this is our first row. Then we have the @ symbol and the second row, which is this one, and the third row. And if I copy this and paste it into Word, so let's open Word here and add a new equation. So paste it here and enter professional, then we have our matrix. Well, we don't have brackets yet, but this can be changed by adding the opening bracket here in the beginning and the closing bracket after the last value here. So if we run this again, and I'll just copy this again and paste it into Word. So change it to this one and press professional, then you'll see we have the matrix with brackets now. But we are not ready yet because our aim was to create a function, and therefore we have to delete the clear all, close all CLC commands and also the creation of the random matrix. And I'll shorten this here a bit. And now we have to set the function back, so function word m. And as we are in the right directory already, we can just create any kind of matrix now that we want to represent in word style. And therefore we'll create a demo matrix, so demo equals random with a size of 8 times 8. Press enter and then we get all the entries, and to set this into word mode we'll just type in the function name, so word, and assign the matrix, and there we have our matrix. Copy it and paste it into Word, with a new equation. So paste and set this to professional. And here we get this large matrix with 64 entries, all just by this function. And to tune this function a little, maybe we can first oppress the outputs here and instead write display of the string at the very end. So first oppress here another output, then disp of s. So if we enter this, then we get the display of the string. And also if we enter clipboard here, then we don't have to copy this manually, but MATLAB will copy it automatically. So enter copy and string s. So this is what we want to copy. And save this. And if I apply this version of our function, so word of demo, press enter. Then we can paste this matrix directly into Word without copying it beforehand. So add a new equation, paste, set to professional, and we see our matrix, which is exactly the one that we have created here in MATLAB. What we can do next is to set the number of decimal places. This means we would have a second input parameter which indicates the number of decimal places we want. So let's name this NKS and define this here in the comment section as NKS is the number of decimal places. And how do we get this into our function? Well, first I'll set here another if statement. So if n-argin smaller than 2, and this simply means if the number of input arguments is smaller than 2, because I want to define that if there's no number of decimal places specified, then the default number of the decimal places should be 4. So after the if statement, we set the NKS to 4. So NKS equals 4 and end. And how do we do this now? Well, at first we have to transform the NKS to a string. And we set ourselves a new string named out, and instead of the 4 we have here, we have to set our number of decimal places, so the NKS. And to do that, we set a new string and combine it with a string cat command. And now we take the percentage symbol, the point, and then we have to set the number of decimal places, but as a string. So that's why we have here num to string and the number of decimal places, so NKS. And finally our f. And now this here is exactly what we have set above. But with the difference, of course, that we can vary the number of decimal places up here, whereas down here we just have this 4 set. And what we have to do next is just to take this out string and exchange it to this place. So we'll enter this here, and of course also at the other places. So then save this and we can try our new function. So we enter word of demo, but now with, let's say, 2 decimal places. Press enter and we already see that MATLAB just gives us 2 decimal places. We can also try this with 3 decimal places or of course, let's say 6. And just to try this out again, we can paste this to Word. It is already copied to the clipboard. So we add a new equation, paste it, and set our matrix to professional. And you'll see that we have the full matrix with 6 decimal places copied really quickly into Word. I hope I could show you that you can save a lot of time by just creating a smart function with MATLAB instead of typing it all down by yourself. So see you next time.